Okay, today I'm going to talk to you about strong and weak acids. We're going to see what makes a strong acid, what makes a weak acid. We're going to look at concentration and how that relates to this. And finally, we're going to have a look at the pH scale and see how hydrogen ion concentration works in that as well. So, first of all, let's think about what is an acid. So an acid is a measure of hydrogen ion concentration. The greater the concentration of hydrogen ions, the stronger the acid. So strong acids, the reason why we call them strong acids, is when they're in solution, they fully ionize. Now what that means is they completely or nearly completely break down to form their ions. I'll show you what I mean by this. So for example, hydrochloric acid is an example of a strong acid. It consists of hydrogen and chloride ions. So in solution, this fully ionizes to produce H plus ions and Cl minus ions. So remember, it's this H plus that means that it's an acid, this hydrogen ion concentration. Another example would be nitric acid, which is made of hydrogen ions and nitrate ions. That also completely dissociates to form these products here. So you see, both of them completely dissociate. Now we'll have a look in comparison in just a minute, because I think it's important to have a look at weak acids. Now weak acids don't fully ionize in solution. They partially ionize. Now the good example is ethanoic acid, also known as vinegar. So you'll notice the big difference is, again, we have a hydrogen ion being formed, but this here is a reversible reaction, which means it doesn't fully dissociate, meaning that we'll have fewer hydrogen ions as a result, because the reaction can go this way or this way because we have an equilibrium. So that's how weak acids are different. They don't fully ionize. So strong acids tend to have a lower pH than weak acids, for example around 0 to 2, whereas weak acids usually have a pH a little bit higher of 2 to 6 because they're less good at giving up those hydrogen ions into solution. So how we describe that is whether or not they fully ionize. So as we can see here, because we don't have a reversible reaction arrow, we just have this hydrogen and chlorine breaking down to form these two ions, or just allowing these ions to be free in solution, whereas these ones, because it's a reversible reaction, we can also have more ethanoic acid being formed, which would mean a lower concentration of hydrogen ions. So these ones partially ionize. Now, we can't get these confused with concentrated, because you can have a low concentrated strong acid or a highly concentrated weak acid. So let's just imagine I've got a big beaker here containing, 1 decimeter cubed of water, and in it we've had some HCl which has fully dissociated. So this would be like a low concentration but a strong acid. So we're still going to have every single acid molecule giving up its hydrogen ion, but is a low concentration. There's not many of those HCl's, full stop. Whereas, let's imagine if I had a concentrated solution of ethanoic acid. So still, each one of these ethanoic acid molecules isn't going to fully dissociate. They're going to partially dissociate or partially ionize, but which gives us this here, which is a high concentration of a weak acid. So concentration and strength of acid aren't exactly the same things. Now, the only last thing I'm going to show you is how the pH scale works. Because let's say, remember, pH scale is a measure of hydrogen ion concentration. So let's say a particular substance has a pH of 4. Let's say for that particular substance, there's 0.001 moles per decimeter cubed of that substance. Now, to get to pH 3, it's a scale where we need to times by 10. So there's 10 times the concentration of acid molecules to go from pH 4 to pH 3. So this would have 0.01 mole per decimeter cubed to get to pH 3. pH 2, the same again. They'd have a concentration of 0.1 moles per decimeter cubed. And to get to pH 1, again it's the same thing. So pH 1 of this substance would have 1 moles per decimeter cubed of those acid molecules. Now to go the other way, to pH 5, you just divide by 10 instead. So if I want to go from pH 4 to pH 5, what's the concentration going to be? It's going to be 0.0001 moles per decimeter cubed. And that is how acids, strong acids and weak acids work. That is how the pH scale works. Thank you very much.